First, I want to thank all of you for coming here today. I'm Art Baudo. I'm a Principal Product Marketing Manager at AWS. And I'm going to talk to you about how to build without limits is the title of our presentation here, using AWS. And I'm going to talk to you a little bit about using AWS, how AWS and AMD have partnered together and worked together. And also, I think one of the best ways and best examples on how to do that is actually to have a customer talk about that. So rather than put a whole bunch of customer examples that you could either believe or not believe and have me go through that, I actually got Neil here today from Netflix. And Neil's going to talk to you about how Netflix has utilized the AMD instances at AWS. And I think that it's a great way to give you some examples of how that has happened here, utilizing some of the most recent generation AMD instances. So what am I going to cover? I'm going to cover what we at AWS see as top of mind from CIOs and others that we're getting feedback about in 2025. I'll talk about some of the AWS innovations in cloud infrastructure and how they make a difference and how they help customers, all of you, and people use the AMD instances in the AWS cloud, I'll talk specifically about our AMD cloud offerings. And then Neil will talk a little bit about compute at Netflix using AWS instances. And then we'll come back with a little bit of a quick wrap up here. So what are some of the top priorities that we've seen and feedback that we've received from customers has been, first, security. I'll talk a little bit about how AWS implements security and how this is our most important job at AWS, is securing workloads and doing that for all of our customers and partners. Second is cost optimization. I know that no one likes to spend more money than they have to. And so how do we take steps to help customers optimize their cost in the cloud and just optimize their cost in general? And then time to value. Speed and time to market are essential for your innovation to get a product out there. How can you do that using AWS? And productivity. It's important for everybody, developer and IT productivity is everything for our customers, the importance of getting a product out the door. And finally, continuous innovation. AWS thrives on a culture of innovation where we hope that the innovations that we deliver help all of our customers innovate themselves. I'll talk about some of our innovations and how some of our innovations we believe have helped customers do their own innovations and actually focus on their own areas of importance. So at AWS, we continually innovate at our own infrastructure. So our first differentiation starts with the physical infrastructure here at AWS. We build on a foundation of excellence. And also, we talk a lot to our customers about price performance, the importance of delivering something, not just the best performance, not just the best price, but combining the best price with performance. We're maniacally focused on price performance. As we roll out our own instances, we talk always about what is the best price performance, what is the price performance associated with the instance that we deliver. And finally, we believe at AWS that we deliver the most extensive infrastructure in the cloud, allowing the cloud to be brought to you wherever you need it. And that's essential because when you're developing on a global and a worldwide basis, you need access to a region or to an availability zone when you need it to deploy on a global basis. And how do we do that? So I thought I would show you a quick global picture here of all of our regions, availability zones, and POPs all at once. This is to show you that we have a global set of coverage here that's available. That global coverage starts with our regions. To date, AWS has more than 36 regions on a global basis, and each of those regions has multiple availability zones. Every availability zone, I'll show you exactly how we diagram some of this out, but every availability zone is like its own data center there. And I'll talk to you about how many of those we have on a global basis. But it's not just regions that we have. We also have local zones, which are smaller availability zones, except that they're populated in distinct large metro regions throughout the globe. Our local zones to date cover more than 34 metropolitan regions, and they make customers able to use them, particularly customers who do real-time gaming, data, and financial services as well in particular. Particularly if you have workloads that need low latency aspects, these local zones work very, very well. Finally, we also offer our Amazon CloudFront, which delivers data, video, and other applications in milliseconds in more than 700 global points of presence. To drive all of this home, as I said before, we have the 36 regions. And within those regions, there are 114 availability zones. So the first thing you can realize is that there are more than 2 availability zones per region in many cases. Some of our larger regions have 3 and more regions that are, availability zones. To date, we have 42 local zones that are deployed worldwide, and there are more than 14 that are available, 14 that have been announced. But I just want to also direct to the fact that I mentioned before about security, and we also have more than 300 security features that are available. So those security features consist of services that make sure that no one at AWS, no AWS employee has access to any workloads that are in there. But we also take steps as well for our customers and on behalf of customers in the cloud. We take steps to look and check to make sure that you don't have denial of service attacks, and we take action for those. That's part of those 300 plus security features that AWS offers. I mentioned our region design earlier. And so how every region, unlike other cloud providers, we have multiple availability zones. Each availability zone is actually physically separated from other availability zones as well. And every region has 2 fully independent and redundant transit centers that allow data to be transmitted across our AWS network and our regions to create a global infrastructure. Furthermore, we do not use other backbone providers. Once your traffic is on AWS, it is only in our backbone. If you are ever attended our own service at reInvent, which we have in November, we also have on display some of our unique networking technology that's available. And I encourage you to take a look at it. We are so committed to network speed as well. We're even looking at developing technology to be able to improve the speed with which we can deliver performance between all of our regions on a global basis. To date, when we look at EC2, which is our largest service and formulates the foundational efforts here, we have more than 850 instances. And I share this not to be proud of a really, really big number, which is constantly increasing, but because this represents our response to customer choice. Customers come to us and ask us exactly tell us what they want, and this is the result of 90% of these instances are formulated by direct feedback from customers that are here. Keep in mind, when AWS started in 2006, we had 1 instance. Today, there's more than 850. But another note about these 850 instances, more than 100 of these instances are AMD-based instances. So for those of you interested in using an x86 instance in the cloud, that is available to you here. The fundamental underlying technology behind our instances is the AWS Nitro system. And there was a time at AWS where we started realizing that fully 30% of our CPUs were being occupied managing the remaining 70% of the CPUs. We decided what we needed to do was take aggressive action in order to make the performance better for our customers. And in doing so, we adopted and we created what's called the Nitro system. The Nitro system is a combination of hardware and software that allows us to migrate many of the management functions off of the CPUs and deliver bare metal performance to customers utilizing AWS systems. Our Nitro system allows us to deliver improved security, and we're so proud of this security, we even had this verified and audited by an external cybersecurity firm, the NCC Group out of the UK. They have also asserted that there is no operator access from AWS to anybody utilizing our systems. So your data, when at rest, is obviously encrypted, but when your data is being utilized in our system, there is no access whatsoever. And beyond that, our Nitro system has also allowed us to offer other increased security services for customers as well. We also offer further isolation for Nitro enclaves for customers, and we do offer AMD SevSMP for customers that are interested in using AMD's SevSMP as well. Beyond this, the Nitro system allows us to patch our own hardware, deliver delivers secure boot and ensures the remote access, there is no remote access. Beyond that, AWS, I mentioned before that customer obsession. We have more than 200 fully featured services. And of those 200 fully featured services, more than 20 of them are AMD-based as well. So we have a very strong portfolio of AMD-based instances and AMD-based services. And we're constantly thinking about new ways to deliver on behalf of customers. So what is our approach to modern computing? I talked about EC2. EC2 compute is the foundation for our computing. And most of our customers, or many of our customers, start their journey using EC2 instances. Using an EC2 instance, you get full control over your operating system and your runtime effort, and you can run virtually any workload. Then, for customers that are looking, they can use our Elastic Kubernetes service as well. It's a highly scalable. It increases your flexibility, and it has seamless community support. And AWS is an active contributor to Kubernetes. And finally, we also offer complete serverless-based solutions using AWS Lambda as well, Amazon ECS with AWS Fargate. It reduces your infrastructure overhead, reduces the amount of work that you need to manage as a customer as well. So wherever you are on your roadmap, whether that is a serverless side or you want to manage stuff using EC2, we have a solution that is available for you. And that's not all. Utilizing the cloud can help save someone energy costs as well. I know a lot of people have sustainability goals that are out there as well. And also energy is cost at the same time. Running your workloads in AWS is typically 4 times more efficient than running those same workloads in an on-premise situation. In addition, running your workloads on AWS can reduce your carbon footprint by up to 99% on AWS as well. This is also in conjunction with AWS's global goals on sustainability, where we are looking to further that by our purchasing of renewable energy and our water positivity goal by 2030. So I talked earlier a little bit about AMD instances, but let me talk to you about how that collaboration has happened here. So AWS was the first major cloud provider to introduce AMD instances back in 2018. And it appears as though this slide wants to go forward, but I'm going to insist it stays here for a second. So we have, as I said before, we have over 100 instances, instances that have launched doing that. And since that initial introduction off of the EPYC Rome platform, we've also introduced, I'll just let it do what it wants. Since we introduced those for Rome, we've also introduced other generations as well, such as Milan, and our most recent generation, our Genoa platform. Well, speaking of Genoa, since the slides have kind of gotten there, I wanted to show some of the range of workloads that are available here. You probably understand our catchy naming of C, meaning compute optimized instances. M, of course, is general purpose. And R is memory optimized instances. So we affectionately call them C, M, and R are the kind of balance of where customers get started. Our 7th generation instances here are based off of Genoa, AMD's Genoa platform. And they actually have more than 50% better performance than the prior generation M6A instances. There's one major change that we made since the 6th generation and the 7th generation instances is that we went from a multi-threaded architecture to a single-threaded architecture, meaning every virtualized CPU or vCPU on our 7th generation instances is equivalent to 1 CPU. That's one of the things that has helped drive that additional performance for customers. This has made our AMD instances offer the best performance of any x86 instance in our cloud. So if you're interested in utilizing and need that performance-based instance, these AMD 7th generation instances are some of the most important. Another first is that we also introduced HPC. So HPC are high performance compute workloads. So particularly instances in perhaps financial services, weather, oil and gas industries, all use HPC high performance compute. HPC workloads, we introduced Our first HPC instance was off of AMD HPC 6A, and we followed that up using HPC 7A. As you can see, we also have some other instances here, including a GPU-based instance that are available. And our most recent launch happened with our Outposts instances that happened a few months ago. I actually covered most of the performance details here a little bit before, and apparently the slide just wants to go forward anyway. So since I covered them, just one note that I didn't cover is that in the introduction of our 7th generation instances, we also improved the memory bandwidth by 2.25 times, which is a pretty significant amount of additional memory bandwidth as well to handle the additional performance workloads that we see customers driving out here. So I mentioned the HPC workloads. I wanted to cover some of the other spaces where we see customers doing development at AWS in the cloud. So customers at AWS range from some of the smallest startups in the world to some of the very largest customers you've heard of. And many of those are using these AMD and AWS instances. And so across the customers that we see and are doing genomic testing. We see customers doing CPU-based inferencing. For those of you that were at Lisa Su's keynote this morning, that was also covered there as well. So I can't emphasize the options that are available, and I want to encourage you all to try some of these instances out. But I think the best way to learn about that is to see some of the performance and see some of that in action. So I want to invite Neil up from Netflix to talk a little bit more about how Netflix has deployed AMD-based instances in the cloud. Neil?
Thank you.
Thank you.
Hey, everyone. My name is Neil Mullen. I lead what we call cloud infrastructure engineering at Netflix. And we've been doing the cloud thing for quite a while at Netflix. And I wanted to talk about the journey we went on with AMD and some recent modernization we've done over the past year or two. So if we look at compute at Netflix, we first off out of the gate have a website that has 300 million subscribers, and we've up to 5 profiles per subscriber. So we're serving multiples of that in terms of actual users. And running a website at that scale, serving hundreds of millions of people, tends to take a lot of compute. Secondly, if you use Netflix, which I hope you all do, that website serves you up exactly what you want. And how we do that is an awful lot of machine learning in the background, which again takes an awful lot of compute. And not alone that, we have to encode video. Not alone do we have to encode the thousands of hours of video that we record each week, but we're constantly re-encoding the entire back catalog at Netflix to the latest AV1 codec to optimize size or to take in the latest iPhone resolution. So for all intents and purposes, we have essentially an infinite supply of time-insensitive compute at Netflix on top of all these other things. And now we're building an advertising business as well as we're doing live. And as we see with other companies like Meta, Twitter, advertising infrastructure can be up to 40% of overall infrastructure. So we've this super heavy compute workload at Netflix compared to a lot of companies. So how we go about getting our compute infrastructure in place is very, very important to us. AMD Genoa attracted us for a number of reasons. As Art already mentioned, AWS made a significant change with how they brought the Generation 7 Genoa-based instances to market, in that rather than pricing per vCPU or per thread, every single vCPU is a real core. And this is a massive difference in terms of compute power over any other generation of instances that are there at AWS. It gives you best-in-class single processor performance. You fundamentally won't get any other instance to match what these things can do on a single vCPU. They are priced higher than others, but we find that they're best-in-class price performance as well for us. For the vast majority of workloads. There's still corner cases where actually M6A or the Milan-based instances are the cheapest instances you will get at AWS. But we've been super happy with Genoa. What really interested us out of the gate was the large SKU size. So again, as Art mentioned, you get up to 256 CPUs in a box with this generation. And that's really useful as the world moves more and more to containers. We run a broad spectrum of compute, serving all of those categories that I talked about previously, from serverless through some very large multi-tenant container platforms that we build at Netflix through legacy, or well, not legacy, through EC2 instances themselves, running many of our workloads. We've been doing this for about 15 years, and we have a very mature process for building Java services and deploying them on EC2. So we have thousands of microservices across these different spectrums of compute. In that middle section of kind of packing these multi-tenant containers, large SKU size is super interesting. You get much more space to aggregate your containers over and hopefully drive a lot more usage. That was what really attracted us. 256 cores in a single box, but interestingly, the sweet spot we've actually found is the 128 core size. That when you get to the point where the largest single socket is now 128 cores, and that's the hump of the curve. And it's now large enough that you can still fit and pack a lot of containers in there, and you don't have to deal with NUMA overhead at all. And Nitro has gotten good enough over the years that there's virtually no benefit to going bare metal. So we found with the move to Genoa, rather than doing bare metal instances for our container platforms, we actually flipped everything to Nitro at the 128 core size to take advantage of the single socket performance. And we found the performance to be effectively as good as bare metal. The overhead there is just non-existent anymore. This is the quote that came out from our performance team when we did evaluate the Genoa instances. The M7A shredded our benchmarks, exhibiting performance that transcends a regular generational improvement. I know Art touted a figure of 50%. I don't know if we quite got there, but it's in that range, and it's certainly a lot more than the 15 to 20% we've seen historically, generation to generation on CPUs. So I wanted to kind of, rather than just talk about bullet points on a slide, get into some of the data as to what we did see when we started evaluating these AMD instances. Given the theme of this conference is AI, I wanted to focus on the personalization aspect of the compute pillars we looked at before. So we do a huge amount of our personalization on CPU because we have this massive fleet of CPUs doing all these categories of work. So we find CPU-based inference is actually the core of what drives a lot of the recommendations at Netflix. So here is how we started to tee up when we brought the Genoa instances in. We've got AMD in red versus what we would have seen historically, running some standard personalization benchmarks. And we're basically seeing how many transactions per second for inference we're processing on each of these servers. And we can see we're doing it with literally half the CPU utilization on Genoa versus previous generations, processing roughly the same number of requests. And interestingly, we're doing it at about 40% less latency. So these were massive wins for us as we started to evaluate Genoa. We also have this interesting concept at Netflix, what we call squeeze, where we push things to their limit. And it's a really generic thing, so we can take just about any workload and push it to breaking point. It's super useful for evaluating how things fail. So we take the same kind of workload again, and we push it through squeeze test. And we start to see in this case that the middle graph becomes the interesting one here. Rather than doing just shy of 1,000, I think we're about 800 RPS in the above slide, through our box as we normally do, we can push up to north of 2,000 without breaking a sweat. We eventually get to the break point, as you can see there. But what was also interesting about AMD is it degrades more gracefully. The curve you're seeing in that middle slide as you start to approach, or of CPU utilization on the left slide, as you start to approach those high requests per second on the middle slide, is a lot more gradual than you would have traditionally seen on an x86 processor. Traditionally, you get to about 45% CPU usage and things will suddenly go off a cliff. Whereas here we start to see we've got a solid plateau at 60%. And we jump up again, and there's another plateau there around 70-something%. But you're starting to get riskily close to where things crashed and burned. But what that has meant in reality is we've been able to shift our ASG thresholds from kind of that 40% point where we were considering that was the hottest we would comfortably run at, to 60%, because we've got this plateau again at 60% with Genoa. So that's literally a 50% increase in how hot we can run the boxes. So actually, I will give Artis 50% improvement there alone, because of the graceful degradation. So that was super interesting to us with Genoa. Netflix, I'm going to move on beyond the personalization. So a lot of the journey Netflix has been on in the past year or so, as I hope you all know, is we're beginning to do live. And we did, I think, the largest live event in history on the internet last year with the Mike Tyson boxing match. To do live means your traffic gets way more spiky. You can have literally millions of people turn on Netflix at the same time. And that's a fundamental difference to the pattern we would have had in the past. And that means you have to have much, much more headroom in your system, or you need to be able to scale much, much faster. So the journey we went on is we set ourselves a goal of we're going to scale multiples faster, be able to ramp these services way faster than we could in the past. These graphs show the journey we went on over a year to drive down aggregate service start time. So you're looking at a stack of about 500 or 600 microservices that are in the critical path at Netflix, and us slowly working to grind down the startup time across those. But what gets super interesting relating to Genoa and the introduction of Genoa is in April last year, we had gotten ourselves really comfortable. We had a bunch of the fleet running Genoa. We flipped 1 million CPUs in a single day onto Genoa. And you won't see this in the US East 1 region, which is our base region and where most of our work goes on. But you can see it in the US West 2 and the EU West 1 region. You can see that dramatic drop in the high percentile start time in the middle of April last year. And that is just the introduction of Gen 7. That's just the performance improvement that Genoa gave us over what we had before in terms of just how fast our services can start. And that was, no engineering. There's tons of great engineering involved in this overall journey to reduce start time, but that one's for free. That's you change your server type, and you got it. So that's been super interesting. We're at a point where the Genoa platform has become the default for many of our workloads. Obviously, we continue to go on these journeys and evaluate everything that's out there that's coming. But at this generation and at this point in time, we find that there's nothing else out there. Now, that is little perhaps unique to us because of how compute heavy we are. Those clock cycles really matter. That single CPU performance really matters to us. But we're very happy with what we've seen, and we've managed to drive a large amount of our stuff running there. So I think that's about as much as I had, and I'll hand back over to Art to close us up.
Thank you. So I think one of the things, I just wanted to summarize some of the thoughts that both of us have had. So see, I don't lie about the 50%, in the end. But first, AWS and AMD together offer one of the most scalable, reliable places to run your workloads in the cloud. AWS and AMD deliver the best x86 performance in our cloud. And AWS and AMD continue to innovate on customers' behalf as well. And I also want to point out some of those stories that Neil had are very similar to other customers that we see trying out the Genoa processor, including the information about also being more comfortable with a higher percentage of CPU utilization. And all of that contributes to the better performance that has been delivered there as well. And for us, it's not a question of, our question to everyone here is also, what will you be able to build and how can you take advantage of these instances as well? And I think we're at time, exactly, otherwise I would have taken some questions. But I want to thank all of you as well for joining us today. And I'm excited to see what all of you can build on AWS. Thank you very much for joining us.